evening, everyone, and welcome to Live the Code 3.0. We are thrilled to have you join us today for what promises to be an insightful and enriching session presented by the Geeks for Geeks ADGIPS chapter. My name is Chetna Madan, and I will be your host for this event. Today's session, titled MLOps with Azure, will provide us with valuable knowledge on how to leverage Azure for machine learning operations. We are excited to have not one but two amazing speakers who will be sharing their expertise with us. Let me introduce our first speaker, Atharva Khedkar, a CS Ph.D. at Arizona and an Ex-SDE intern at AMD and HackerRank. Atharva has vast experience in software development and he will share his insights on how MLOps is transforming the world of machine learning and cloud technologies. Our second speaker for today is Atharva Malode, an AI/ML intern at CSIR-NEERI and a Beta's Microsoft Learn Student Ambassador. His expertise in artificial intelligence and machine learning, coupled with hands-on experience in the industry, will guide us through how Azure plays a significant role in the deployment and scaling of machine learning models. With that said, let's not keep you waiting any longer. Please join me in welcoming our esteemed speakers, Atharva Khedkar and Atharva Malode. And now let's get started with the session. Atharva Khedkar and Atharva Malode, now the stage is yours.
Thank you so much, Ms. Chetna. I'll just try to share the screen. 1 second.
Yeah, can you confirm? Is it the screen visible?
I didn't see it. Do you guys see the screen?
Just a second.
Yeah, now it's visible. Perfect. So, hey guys, welcome to this session. In this session, we're going to discuss some of the basics of what exactly is MLOps, what's the difference between ML and MLOps, and then we're going to proceed with some demo of what Azure is, what are Azure Cognitive Services, and how to deploy your model. So by the end of this session, you'll be able to deploy a basic neural network or any other model on Microsoft Azure platform. And you'll also have a hands-on session in like 20 minutes at the end of the session. So what exactly is MLOps? So MLOps is a very fancy word which have been going past here for like for at least like 3-4 years, and this field has been evolving so much. Everyone has been talking about ML since LLMs came up, right? But now with MLOps, it's not just about model development, it's all of these things. So how do you meet your design? What are the ML use cases prioritization? What data is available? How do you do your data engineering and modeling? And the most important part is, even after developing your model, how do you deploy it? So what are your CI/CD pipelines? How do you scale your model? All of these consist of MLOps. So it's kind of like your data operations, and then after that, how do you develop your model, and then how do you deploy and launch it? So if you want to see the exact steps that are available, like that you need to do inside MLOps, these are some of them. So you start with getting your data, you're pre-processing your data, selecting what model works best for you. Then you try to deploy the model, you test and validate your model, you deploy it, you monitor your performances, and then you try to retrain. So this infinite loop, or this loop of updating your uh, model continuously, is nothing but what's called as machine learning ops. And if you can clearly see that this light blue area is what machine learning is, but if you see the dark regions, the combination of this light blue and dark blue region is nothing but machine learning operations. Okay, so I think now we have some clarity about what's machine learning and what's ML ops. But now let's see what Azure is. So there are multiple cloud computing platforms online. Let's say Google Cloud, Microsoft Azure, AWS. So Azure is one of the most popular cloud service platform that has been provided by Microsoft, and it's free to use up to some credit limits. I think it's like $100 for students. So you can sign up on Azure, and then you can try to deploy your machine learning apps. You can try to create your website. There's endless possibilities that you can do with Azure. So it's a cloud computing platform, and it is like using a virtual space on internet to store your data and run programs. Azure will also provide you with a range of services and tools that individuals and business can use to build, deploy, and manage your applications. And some of the services that we have mentioned are like virtual machine storages, databases, networking, and a lot more. So when we say model development or deployment, what do you think it is? How is it different than web development? We don't know what, like, how do you distinguish between a web development and a ML model development? So if you see, there's not much difference. In web development, you would have something like a front end and a back end. So you would have your React code, or like you'll have your HTML, CSS, whatever, the front end. And in the back end, you'd be serving it with different different applications. For example, if you have Python backends, then you may be using one of the three that we have targeted below. It could be the Flask, Django, or Fast API. So similar as web development, in machine learning model development, you'll also have a front end and your back end, which will be a model that will be served as an API or a service. So you can send requests to your model and get feedback, or like get the validation or the outputs from your model, which will be served by either one of these three backends. So out of these three, we are specifically going to target on the Fast API because it's one of the new ones and the fastest Python frameworks, which is very ideal for high performance applications. And because it's in Python, it's very easy to deploy as a backend, and it uses Python type hints for automatically validating data and type safety. So Fast API also generates some interactive API docs with Swagger UI and Retalk. So you'll see what that is, and this is not provided by like any other Python backend. So one of the favorite features of mine in Fast API, and it also has some built-in async support, which makes it perfect for scaling and efficient applications. You'll know what all of these terms are shortly. So now you know a little bit about ML, MLOps, what a backend is, what Azure is, but do you want to know how to create a backend and how do you make it accessible? So some of the classic memes on internet that we see that, hey, I built a website. Where is it? Oh, it's on localhost. And yes, obviously, you can see my like a local host, right? If I host it on localhost, then you must be able to see it. No, right? So even if you have built an ML model or created a website and you have developed a backend for it, you have to ensure that it's available to everyone online. So how do you do that? You have to host your application. And where do you host your applications? On the internet, but how? Using one of the like cloud services or any other hosting services. So in our scenario, we are going to use Microsoft Azure and try to host a machine learning application. Sounds good, right? So the service inside the Microsoft Azure cloud service that we're going to use is this app services. This app services adds the power of Azure to your application, such as security, load balancing, auto scaling, and automated management. So this app services platform is where you're gonna host your ML model, and these it has these web app features. It will automatically scale your application in case you have too many users pinging on your data, and it's a mind-blowing feature, I guess. Okay, so how do you do it? So we are going to take a two-step approach of how do you create your application or your ML model and how do you create a backend for it. So this is your step one, which runs locally. And then step two is how do you wrap all of your local application inside a container that is a Docker container. And then you publish this Docker image on Microsoft Azure, and then you host it as an app service on the Microsoft Azure App Services. Sounds good, right? So as I mentioned, these are the steps that we are going to take, and you're going to see a very live session of how it actually works, and you'll be able to build an object detection model, which will be hosted online, and the code will be shared with you, where you'll be able to ping a request, and then you can get responses. Basically, you'll detect objects. For example, you can detect if there's a human in the image or there's a car. Okay, I am audible, right? Because someone in the chat says audio check. And by the way, if you have any questions, you can post it on the chat and we'll be taking it on the go. All right. Can we go to the next one? I think we are gonna start uh, a live session right now. So let's begin. Malode, you excited?
All right. Thank you, Atharva, for giving an overview. So, as Atharva told, what exactly we are going to do is we will start with running our app locally, and then we will build a Docker image of that. Once the Docker image is ready, then what we are going to do, we are going to push that Docker image in something known as Azure Container Registry. So basically, Azure Container Registry is nothing but a place where you can store your Docker images and pull them or either push them a new image whenever you need it and as per your choice, right? So what we are going to do, we are going to first create a container instance on Azure. So, and after that, what we are going to do, we are going to build the image locally and we'll push that image to that container registry. Once this small part of building an image in the local machine and pushing this image running locally to the container registry, after that, what we will do is we will make one more new instance that is Azure Web Apps instance. And in that instance, what we are going to do, we are going to pull that image which we have pushed in container registry. So I guess it sounds a little bit tough, but we will make it easy. It's not going to be so tough for us. So before I start, let me give you a small overview of the project repository we have. If we start with this, okay, whenever we start a Python file, we have to install some libraries, right? So I have listed these small libraries in the requirements.txt file. We can install it using pip install -r requirements.txt command. And once all the libraries are installed, what I've done is I've used Fast API framework, right? So let me give you a small overview of what this piece of code is doing. So basically, there are two routes. The first one is the get, and the second one is the post request. I guess get request is completely simple. No need to go behind it. It is just simply returning a message saying, "Hello geeks, let's make deployment with Fast API easier." Okay, there's a small spelling mistake. All right. And what next? So next is the post request. What does this post request is doing? As you can see, it is accepting an image file, and once they get the image file, it is going to do some pre-processing, and it is going to pass it to the model. Which model? YOLO V8, standard YOLO V8 model, which has been saved here. Whenever we train our ML model, we basically save that ML model in some .pt format, or you can say .h5 format. Basically, we are just saving the weights, whatever the model has learned. So if we use TensorFlow, we save it using h5. If we are using PyTorch, then it is saved using .pth, or you can say .pt. You can also use something like Pickle, or yeah, there are many more options used for serialization. So these are few ways. From that, we have used a .pt format. So the learned weights are here only. Okay, then this is a small overview of the main.py file. This is too small piece of code and it is easy to understand. And talking about the Docker file, it's just like an recipe to make some dishes. Like for example, let's say you want to make something like you want to just make something like some Indian cuisine, like okay, let's take an example of Maggie. If you want to make that, how you will know how to make it? You can ask your friend to note down all the points, what type of ingredients to use and all. So some type of similar concept is used here. What we are going to do is we are going to create a Docker file where each and every step will be listed. What steps will be listed? Starting from basically, let's say what we need Python, right, to run the localhost or to run the fast API backend app, right? And for that, we have taken this from Docker Hub, that is from Python 3.9 Slim Docker image. We have taken that from Docker Hub. Then we have set the working directory. So basically, to give you a small idea, whenever we talk about Docker, so it runs on Linux, and we have to specify each and everything, that where our project is going to run, in which folder we are going to keep our code, like that. So that's why I've set the working directory as app. So basically, app folder will be there. Inside that, my all the code will be stored. Now what I'm going to do is I'm going to copy what dot means each and everything available in the current directory, right? As you can see on the left side, each and everything present here will be copied where? Inside this app folder, right? And once you do that, after that, as I said, we have to install the requirements.txt file, and we have to also upgrade our pip. It's not necessary, but it's good practice to do that. And then these are few things which are required by OpenCV. Yeah, basically, okay, what is OpenCV? OpenCV is a library used to handle image data, right? So these things are basically needed when you are working with CUDA inside a Docker. And apart from that, also these are needed. So as of now, don't think too much about this. These were just required. That's why I've added them. And next, what is it? Okay, we are trying to expose some port, right, from our Docker container. So what is going to happen? Our app is going to run locally inside a Docker container, and from that Docker container, some port is to be exposed, right? So that port, we are going to expose that to our browser so that you can actually view it, what all is going on in that port number, right? Because Docker is kind of a isolated environment, right? So we have to expose something to outer world also, so that these two things can communicate easily, right? And then what is this? This is nothing, just a command to start our fast API backend. If I show you by running it, just simply type uvcon main app and hyphen reload. Basically, this main is referring to the main.py file, and app is referring to the fast API backend app. And this hyphen reload is whenever we try to make any change and save this in the main.py file, it will automatically reload. So that, okay, what's okay? Sorry, I have to activate the environment. I just forgot. Okay, all right. So now if we run it, yeah, as we can see, the app is running locally, not in a container itself, nowhere in a simply in our local machine, right? So if we open that port number somewhere here on the local host, it was 8000 if I'm not wrong. Okay, let's see it. Yeah, all right. Oh, look, it is working. Now, as Atharva said that there is an inbuilt feature inside the Fast API where if you just simply add docs here, it gives you an Swagger UI. Just to test your APIs, we can say, right? So if you want to test it, simply hit on this root and then hit on a write out button and simply click on the execute button. And yeah, you can see it was a successful request and you can see the message right now. Now you can also try it with the post request. We will try it once. Okay, then just let's choose the image. Let's take this image. I've already downloaded it. Once the image is uploaded, just hit the execute button. It may take some time, maybe a few seconds. And yeah, all right. Okay, it has given. Yeah, you can see object detection part, right? Now the thing is this entire part is running locally, right? And what our aim is to get a simple link which we can share with anyone and he or she can easily use that. That was our overall aim, right? So let's head towards that part and not focus on this. I'm just, yeah, you can see here like these are the dimensions of the image and how much time it has taken and all. We will close this port now. It is of our no use. Yeah, all right. Oh, yeah, by the way, if you want this code, you can also get it from my repo. I have posted it for you all. If anybody is there who want to do perform this entire stuff with me, then you can get this template sort of thing from here. And yeah, each and everything I've pushed out here, right? Okay, now let's focus on the image building part. Now, as I said that we have to build a Docker image, right? Now, how we can build a Docker image? For that, we need some steps written somewhere, right? So I have that steps written where? Written in this Docker file. So I will simply do a simple thing, that is I will write a command that is Docker build. But before we do that, just make sure that you have your Docker desktop turned on. Yeah, guys, you will need this Docker desktop whenever you are, what we say, building a Docker image. That is a mandatory thing. Or you can also write a command to start the Docker daemon. It's an optional thing. In my case, I'm starting Docker desktop. Okay, so is the Docker desktop running? Yeah, I guess I can see it. All right. So it will start the Docker engine. Let's close it. You don't have to do anything here. You just have to start it and that's it. You are done with it now. It will take few seconds, I guess. Okay, let's wait till the time it gets refreshed. By the way, guys, you can ask your question sort of thing in the comment box itself, and I will be happy to answer that. Okay, I guess it's done. Yeah, all right, it's done. So now to build a Docker image, what basically we do is we write a command that is Docker build. There is nothing fancy, simply Docker build. All right. Now, if you can see, I have written Docker build and a hyphen T. Hyphen T basically means tag, and this is my image name MLOps, and this is the tag I have added v3. It's an optional thing. If you don't want, you can't. It's fine if you don't add it. Okay, and then I have added a simple dot to represent the current directory, and I'm just entering. I'm just hitting an enter button. All right, so it is building an image. So guys, it is going to take some time, maybe 15 minutes or 20 minutes, or sometimes it may also take 35 minutes also. So I'm not going to move inside that. I've already built one image and I'm going to use that as of now. Fine. If I show you, if I write Docker images, one more command, yeah, and you can see that I have image named MLOps with a tag named v2 and with the image ID itself, right? Okay, all right then. So I have that image, right? Now what I have to do is I have to check whether whatever container or whatever image I have built, it is running or not. Where does this image run? Image runs inside a container. Container is just like an isolated environment where I have defined each and everything, what to install and what not to install, right? So if we run this, just simply write docker run. Okay, some spelling mistake. Yeah, all right. Now you must be saying what is this hyphen p or flag p basically. Then what is this port number and what is this? Okay, let me tell you. Basically, this is something I'm exposing the port number. So this is the port number of my container and this is the port number of my personal local machine. So I want my container to point towards my personal, my local machine's port number. Fine. And this is my image name. That's it. Nothing new and nothing fancy. So I'm just hitting an enter button. It will take some 4 to 5 seconds maybe. And once done, we can test it on the port number 8000. Okay. It is taking time. Okay. So let's wait. Somebody was asking regarding the code, right? I will share the link of the repo afterwards, or I will share it with
We've
the team
posted it
itself.
in the chat.
Okay, yeah, sure.
Yeah, it's
Okay,
already
yes,
posted
posted.
in the chat. So feel free to check around the code
Uh,
and try to deploy it yourself as well.
okay, so yeah, now the Docker container is saying that they have done it. You can open it and you can test it, right? Okay, let's open it then. Simply just open your browser and look, I'm closing this. I'm closing this, the one which you have used, the one which we used earlier. Sorry. So yeah, localhost. It was 8000, I guess. All right. So look, the app is running right now. I'm not going to test it because we have already done it. We will test it once it will be deployed as an uh, clickable link. Okay. Now it is running on my localhost itself, but inside a container this time. Okay, so once done, let me close this about it. Okay, done. Now, what our next step is, we have built a image locally. We have pushed it inside a container locally, and it was running completely fine locally. Right now, what we have to do is we have to push this Docker image to Azure Container Registry. So to do that part, what we will do is, okay, I have Azure already logged in. All right. Yeah, so it is taking some time. Okay, so I have logged in on my Azure portal, and now what I'm going to do here is just go and search for container registries. Okay, we have it here. If it is not present here, you can search in the search bar and you can get the container registry part. Okay, right. So what you have to do here is we have to just hit on create button. Uh, just a second. Okay, it is now. Once you hit on the create button, uh, it will ask some details. Let's make this resource group as event test and what name to give. Let's name it Atharva 101 itself. Okay. Hopefully it should be available. And I will not touch the location because I'm just using it for. I'm just going to make it and destroy it after a few minutes. You can choose the plan as per your need. I guess basic one is free and standard and premium if you want to use it. In my case, I'm keeping it standard and I'm just hitting the review plus create button. Okay. Um, okay, it is asking me for some details. Okay, no, nothing. Fine. So just hit the create button. It will start the deployment process where it will make a container registry, which you can freely use it. But I guess I already have one. Okay. So by that way, if it is taking time, I can show you the one which I have already made. Where it is? It was this one, I guess, right? Let's check this one. Yeah, this is. Now, if you open it, Right. So you can see the login server name, you can see the container registry name. So you just need these two things once done to push our image from locally to Azure Container Registry portal. Fine. So let's head towards our VS Code and let's start with it. Before you start with this, guys, you just need your Azure CLI installed so that you can easily log in, right? So in my case, if I just do AZ login, and after I guess 2 to 3 minutes, 5 or 10 minutes, you have to do it again. So it will authenticate. In my case, yeah, I have to select my account and done. Once done, it will automatically tell on VS Code that it's been done. Okay, let's wait for it. What's wrong? Okay, done. So once done, just that's it. This means you are logged in. Just check for the login succeed option. That's it. You don't need anything else. And guys, by the way, if you think that like these commands are not something which you can write now, I have already added that in my readme.md file. You can use it from there. Feel free to use them, and you just have to copy it from there, and you can use it. That's it. Just replace the name of the container registry, name of the Docker image, whatever it's been kept there. Fine. Okay, then once you have done this, you have logged into your Azure portal, right? Now you have to log in your ACR, that is Azure Container Registry. For that, you write AZ ACR login, and this is the name of your container registry. Fine. Once you have put that, basically hyphen n stands for name, and yeah. Okay, so it's been processing. So it will take some 4 to 5 seconds of time. Let it happen. And once done, you will get a message saying login succeeded, sort of thing. Fine. So once you get that message saying login succeeded, then you are done. You are done logging in with your Azure Container Registry, right? Now what you have to do is you have to push the image. So before pushing the image, what you have to do is you have to tag your image which is present locally. Yeah, you have to tag that with this name. So basically what I'm trying to do is docker tag, and then this is the name of my image with a tag name that was v2, which I have made. You can check that in docker images. And then this is the name of the container registry, from where I've got that from what we say Azure portal. And this is something which is just tagging it. That's it. And if you hit enter button, simply it will tag the image. Now in my case, I have already done it, so it will throw an error. If you want to see, I can show you. Yeah. If you can check it here, see. So this image has been already tagged, right? That's it, right? So this is the thing which you have to do, and once it is done, it's done. And the size, guys, I have used a basic image. You can try using different methods to reduce the size. That is completely up to you. I was just using it for demo purpose, that's why. And once done, this means you have tagged the image and it is available in your current directory, current Docker images part. And now what you have to simply do is you have to push it. That's it. A last command maybe. And using this, you can easily push it. Okay, just hit the enter button and see it has started pushing it, right? So I have already pushed it. I'm not going to do it because it takes nearly maybe 20 minutes or 25 minutes depending on the network connection and also the size of the image, right? All right, so basically this means we have made our Docker image. We have tried running it locally, and then what we have done is we have tried pushing it to the Azure Container Registry part, and that's it. Done. Now what our last aim is to deploy it as a web app, right? For what you all are waiting, right? So for that, simply log into your Azure portal once again. And then once you have logged in, what you have to do is you have to just make a app services part, where you can create a new web app, not a web app, yeah, a web app. And let's do it. So yeah, here you will have to fill out Basic details like gives the resource group and what name to give. Uh, let's give it Atharva only, and let's make it 101. Oh wow, it's available. And then guys, make sure you select your container part properly, right? I'm hitting the container button here, and then operating system is obviously Linux, and region you can keep the default one or you can change it. It's all up to you. And it's taking some time. Okay, and you can also select the Linux plan. Basically, you can select or change these details, or you can keep the same and hit on the review plus create button. Oh, sorry, not review plus create. Hit on next container button. Now, once you come here, what you have to do is you have to select the image which we have recently pushed from our command line to Azure Container Registry. For that, we have to, in image source part, we have to select Azure Container Registry. By the way, guys, if you have your image in Docker Hub or any another registry, you can also pull it from there. It's completely optional thing. In our case, we have used Azure Container Registry, right? And then, yeah, it is a single container. Let's select the registry. It was fast API backend, and it will automatically give me options of how many images are available. And the tag, there was only one image that was MLOps, and with only one tag that was V2. That's why it is giving me only two options, or else you can get more options if you have that. And just hit on review plus create button. So now it will take some time, maybe few minutes, and after that also, once the deployment process is completed, it takes nearly 3 to 4 minutes, if 3 to 4 minutes to start the app. So I have the one already deployed. We will create this one also. Yeah, till the time it, okay, let's wait for few seconds, and then I will show you the one which is already being deployed, which you can open it, you can share it with your friends, you can test it live now in the event itself. So yeah, it is taking some time now, right? So guys, I hope I am able to keep the things little bit slower, because the person who is doing it for the first time, it will be difficult for him to understand the things. But once he get habitual with this all, it will be like a piece of cake for him. Okay, fine. So yes, there's some network issue from my part. Now this is the default domain. You can also replace it with your own domain name also. Like if you have a name something like whatever domain you have purchased, and you can just simply open this. Yeah, I guess it is going to take some time to load. Till that time, I can show you the one which has already been working. I guess it was this. Yeah, this is the one. And if we open this link, oh look, see, it is working. And now you can share this link anywhere. You can replace this thing with the proper domain name, so that if you have your startup, or if you are pitching it for a hackathon, if you have a domain name with the like if you have a domain name with you, you can replace that also from the Azure portal itself. And okay, just a second, let's test it from here. It's working, right? Okay, so let's use this root one part. Let's make a simple call first, and I hope you guys are getting the things and they are not too much difficult for you. Okay, so I will, just a second, let me share a link, and yeah, by that way we can try it out from here and hit the execute button like this. Yeah, so you will get a link in the chat box itself by someone. Yeah, now what we were going to test are detection part, right? So talking about the detection part, where it is? Array. Sorry. Actually, I haven't opened it. That's why. Hit the try it out button, and then you have to choose a image. Where is the image? Let's take this one. Yeah, and let's hit the execute button. It may take few seconds, maybe 4 to 5, but okay. Wow. So see, it has detected a car. It has detected two persons in the image. Now you can test it as much as you want. And if you want, we can also test one more image here. Yeah, that's it, guys. So we can say that you have deployed this ML model which was saved in a .pt format. The basically the weights were saved in a .pt format to a clickable link. Right now, you can use these APIs wherever you want. Even you can test it with your Postman. You can test it with your front end codes, like whatever you want. It's completely up to you how you want to use it. So that's it, guys. Now, if you have any queries, you can ask them, and if you want to know something, you can also do that. And yeah, by the way, each and every command I have added here in the readme.md file. If you can see, all the commands I've added, and it's only about writing few commands. That's it. I guess 5 commands. That's it to deploy an app. But it will take some time to build the Docker file, basically. All right, then. That's it, guys.
So thank you so much, and we've also posted the link for this deployment in the YouTube chat. You guys should be able to see it. So if you have any questions, please let us know. We are up for Q&A. Okay, so the first question, what if you want to use the Kubernetes here and why do you want to use it? How can it help? So Kubernetes is actually for container management. So if you have a very large scale application, let's say, let's say Google, for example. So Google is used by billions of millions of people per second, right? And you can't just deploy one app and hope that everything works best and everyone is able to access it. So how do you do it? So for those, what actually happens in the back end is they have multiple servers that are continuously like deployed and updated. And if you have more requests, then a new server is automatically created. If the requests are very less, the created servers may go idle or get deleted. So they have this very vast deployment. So this was how you deployed one container. And because we are doing it on Microsoft Azure platform on the app services, it automatically takes care of the deployments. So in case, so you can actually set the scaling in that. There's a thing called as auto scaling. We would want you to try. And in auto scaling, you can, so for example, if the total CPU load or if the total number of requests is exceeding and the CPU is not able to handle it, then they will automatically scale or clone your container into 2 or 3, and that is good enough. So that's why for this particular scenario, because we are using app services, we get the scaling features, and that's why you don't want to get into Kubernetes. But it's a really cool thing to try out, so feel free to try it out. Okay, fast API or Flask. Malode, do you want to take this one?
Yeah. No, you can take it.
Okay. So Fast API or Flask. Let's see. So actually, there's one more platform, and it's called Django. So from what I've seen from my experiences, so Flask is very quick and efficient way to do it, like deploy your apps or create a backend. Django is more like mostly used for large scale platforms, I think, and some people have it in production as well. So it's a very good framework for deploying in production. Fast API was newly developed by a guy, like not so new, maybe like 5, 6 years ago, I guess. But it's a very good service. The best part is Django is a bit complicated to write compared to these two. Fast API and Flask is very easy to write. So in Fast API, with the same ease as Flask, what you get additional is the docs feature, the Swagger UI that is automatically created to test your APIs. And technically, like lots of people have been liking it all across the internet, and it has been like starting to get more popular to uh, get your deployments running on Python. So that's why maybe like previously I've used Flask, but even now I've like started to like change to Fast API because it's much more faster and convenient, I guess.
It's like it makes testing convenient for us, like building an API and then easily we can test it in fast API. And for Flask, we have to use depend on some external tools like Postman and all.
So, what are the future opportunities and internship prospects in the field of AI and ML? Wow, that's a very that's a very vague question, but okay. So, future opportunities and internship prospects in AI. So, by the way, both of us are have done bachelors in artificial intelligence actually. So, we have been learning ML and AI at our college curriculum and online as well. And like I have completed my bachelor's and currently I am doing PhD at Arizona State University here in the US. So it's early morning 7 a.m. for me as well, guys. But the thing about getting internships and opportunities is you can just I mean there's a lot to do actually. So for example, I've done internships during my bachelor's in AMD and at HackerRank. So I had AI projects there, and I deployed and built some ML applications for AMD and even as well for HackerRank. So all you have to do, I guess, is just like showcase your skills and expertise in these fields, and you should be easily able to grab the opportunities for internships or full time even in these fields because these are very much in demand nowadays. So I think it's doable. I know because I've done it. So. Okay, so can you compare Azure with other tools for ML testing like TensorFlow or PyTorch? So TensorFlow and PyTorch are for developing your machine learning applications or like training and building your models. And then after you have deployed or after you have created your model or trained your model, then when you try to deploy it, you do it on one of the like n number of cloud platforms available online. So one of the most popular cloud development platform is Microsoft Azure, and it's very convenient to use. So that's why for this scenario we chose Microsoft Azure. So very different use cases, I think. I don't exactly know if there's some testing available for TensorFlow or PyTorch. I think TensorFlow has a deployment option like TensorFlow Hub, but I've never tried it. And I'm not sure about PyTorch. Okay, primary differences between CNN and KNN in terms of performance and use cases. So CNN and KNN, even if it sounds very identical, it's like a difference between a car and a carpenter. So CNN stands for convolutional neural networks, while KNN is K nearest neighbors. So KNN is a like statistical machine learning approach where you don't do any training and then you just try to cluster your data together based on the data set. So you just try to find your nearest neighbor. So your 5 nearest neighbor for your current testing, 5 or 10 or like whatever hyperparameter you select. So any of those in your testing set, that will be your classification or your regression value. But in CNN, you try to train a convolutional neural network, you try to make it learn weights. So the differences that you'll be seeing in terms of performance and use cases is like if you have a very small data, let's say like I don't know, if you use Iris or Titanic or all these famous data sets, or if your data is very limited and it's mostly numbers or it's statistical or some strings, so it's not a very complex data is what I'm trying to say. Then you can go for statistical machine learning approaches because they are very fast and you can instantly see very good performances. So I've seen even in deployment. So, for example, my time in AMD, we actually tried statistical machine learning approach. Like we had some tree models that were deployed in production. We didn't go to neural networks at all because it was very convenient, and we got the we got very good performances. So we didn't need to go there. So very easy data, KNNs. If you want to do something complex, for example, object detection, image, and some let's say any other use case, for example, NLP and all that other stuff, then you would like to go for CNN. Okay, next one. Um, I'm a fresher and I wanted to know how to get started with MLOps. Can you please provide a basic roadmap for us? Hmm. So for MLOps, I actually try to do some Coursera courses. So probably go on Coursera and search for TensorFlow Professional Development Certificate or something. So it's a combination of like 3 or 4 courses. It gives a very good hands-on experience of how to build your models and train it on TensorFlow. So that I have done, and after that for deployments, you can obviously like check this YouTube video. But apart from that, if you want to try deployments, I don't know any good resources that you can try. Malode, do you know any resources that we can give?
For MLOps part, yeah, LinkedIn Learning also is a good option, I guess, because
Okay, so
because
yeah,
I've
LinkedIn
tried.
Learning is what I tried. Mhm. So maybe just try to go online and find these courses, and you should be able to do it. So, is it true to get a job in ML role? Master's PhD is important as many people specify that as a requirement. Huh. Yeah, so actually they posted that master's or PhD is required or something like that. But it's even for beginner roles they posted. But the as I said that if you are able to mention that you already have experience and you have what it takes, then you should be able to get these roles. So beginner like I think machine learning engineer can you may be able to achieve it given you can show in your resume that how of a good fit are you, then it doesn't matter much because like in AMD maybe they would take bachelor's interns, I don't know, but like interns previous to me and the team I was working with, mostly they used to hire from only masters. They didn't consider bachelor students as well, and I was the only bachelor student there working as an intern. So that was because I was able to show my skills, and that's all it needed. ML role versus SD. Wow. Okay. I think both are really good and both have their different set of expertise and in demand. So let's take it this way. If you try to develop very good machine learning models, then you'll need to deploy them and you'll need to test them and you'll need some software which can host them online and I don't know, like provide a front end and all. So rather than being competitive, they kind of work hand in hand. because like ML, everyone is drifting to anyways. So you're trying to implement as much as ML possible in real life applications. So ML is going to be there. It's a very good scope for research perspectives at least, and even for industry, because industry is starting to adopt ML as much as they can. And SD has been here for a very long time, and it's still going to be evolving and like exploding. So all these new frameworks, for example, initially every like application, large scale application was being written in Java. Now people are trying to shift to JavaScript and like Python and all the other applications that are available. So even to convert that code or do these things, you need better software engineers, right? So both of them have better scope. I don't think it's a like debatable question of where would be best, but it's rather than putting it that way, you can take it this way that whatever you like, try to do it. Will these steps work for deploying other ML models? Malode, do you want to take it?
Yeah, yes, Chaitanya. Obviously, this steps are going to work for other ML models also, but you will have to make some basic tweaks like you will have to, you can say, replace the .pt file with your own model itself, and the requirements part where you will have to add few libraries or remove few whatever needed as per your environment. So definitely, these steps are going to work. Nothing is going to change here. That's it.
Um, that's all the time we have for questions today. A huge thank you to Athar Khedkar and Athar Malode for sharing their expertise and guiding us through MLOps with Azure in such an engaging manner. I'm sure everyone here has gained valuable knowledge to apply in their journey. Thank you all for attending this special session at Live the Code 3.0, organized by Geeks for Geeks ADGIPS chapter. Don't forget to join us for more exciting events throughout the hackathon. Thank you.